go.
Action.
Here we go. So one of the hardest things here is trying to determine whether a salt, any ionic compound, is acidic or basic. So here's what we do. We essentially do this. We remember CBS pin and remember 1 strong Calbert. And then what we do is we take the front part of the salt and we put it together with the base portion and see whether or not it's a strong. And we do the opposite for an acid. Now that doesn't make very much sense. So here's how we're doing this. Whenever you have a conjugate of a strong acid, do you realize it's a pathetic base?
Yes.
So if I have HCl, the conjugate of HCl is Cl minus. Cl minus, if it's left to its own, will it ever grab H pluses and reform HCl? I'll say it again. If you have HCl, which is a strong acid, one of those CBS pinners, right? Mm-hmm. It will 100% break apart into H plus and Cl minus. That Cl minus will never grab that hydrogen and reform the HCl because strong acid by definition 100% dissociate. There's not an equilibrium formed. That means if I took the Cl minus, which is the conjugate of a strong acid, that Cl minus will never grab a hydrogen to do anything.
So strong acids never have a reverse reaction?
They do not. They do not. So let's say Cl minus is part of an ionic compound. That Cl minus will not hook up with anything to produce H pluses. Similarly, and I'm going to take the example of NaCl. So if we take a look at NaCl, Na plus, isn't that the conjugate of NaOH?
Yeah.
Right? If you have Na plus, or if you have NaOH and Na plus, they're the conjugate of each other, right? So the way we look at it is this: if NaOH is a strong base, right? The Na plus portion of it, the conjugate, is going to be an extremely weak acid. It's not going to be able to do anything. It's not going to be able to grab OH minuses or do anything to reform NaOH. Agree? Salts that have cations of strong bases and anions of strong acids have no effect on H3O and hence pH. So if I know that I have a conjugate of a strong acid and a conjugate of a strong base together, they will have no effect on pH whatsoever. No effect on H plus. So how do we break this down? The cheaty way of doing this is to add an OH to the end of the cation and see if it is a strong base, and add an H plus to the front of the anion and see if it's a strong acid. So let's take a look at the salt NaCl. So the cheaty way is this: I'm going to take my Na and I'm going to think of what would happen if I had an OH on it. Wouldn't NaOH be a strong base? Right?
Yes.
So that means that the Na plus of this, which is the conjugate, is a terrible acid. In fact, you may think, how is Na plus an acid? Remember how we talked a little bit ago and we said that we're not going to talk about Lewis acids or Lewis bases? This is a Lewis acid. It is one that wants to gain an electron. But as far as we're concerned, this, when we put it together with this OH minus, this is the conjugate of a strong base. Therefore, this will do nothing if I throw it into water. Do you follow this? Na plus thrown into water will float around there, never reattaching with OHs or H pluses or anything. So Na plus, this portion of it is going to produce a neutral solution. Then we take a look at our anion. So we take the anion and we put an H plus in front of it. So we put an H plus in front of our Cl minus, right? What is this? HCl, what do we call that? Isn't it a strong acid? So if that's a strong acid, wouldn't that make this, the anion, the conjugate of a strong acid? Wouldn't that be pathetic base?
Yeah.
So if that's a pathetic base, that means that this is also neutral, which means that neither of these two things will do anything in water. Therefore, this is a neutral salt. Yeah? Now,
So when something's neutral, it doesn't do anything.
when something's
with
neutral in water, it means that it will do nothing in water. It'll just float around. Which is why we throw table salt in the water, Na plus Cl minus into water. It will never change the pH of water. It'll make it salty because it's Na plus and Cl minus, but it will not do anything. So let's say I gave you this example. Let's use the same one that we already know. Actually, let's do this. Let's do K,
I'm so confused.
KF.
I don't know.
KF.
Okay.
Okay.
Okay? So Kf, this is an ionic compound. We know this because K is a plus and F is a minus, right? The question is this acidic or is this going to be basic? What we're going to do is we're going to pretend that both of these, we're going to pretend our cation, we're going to put it together with OH minus and see what happens. And we're going to take our F and we're going to put it together with H and we're going to see what happens. See whether or not, what type of acid or base we're forming. You're doing puppet shows? That's the life.
No, not you yet.
Okay, so watch. If I put K together with OH, right? What's KOH? It is a strong base, which means that this K, if it got kicked out, right? This K plus would be a pathetic acid. Pathetic acids do nothing in water. They will not reform, they will not grab OHs, they will not do anything. And incidentally, in case we're forgetting, water has this. It has H2Os, it has H pluses, and it has OH minuses in it. Are you aware of that, right? So if I throw something into here, let's say I throw a K plus into here, we need to look at what things it could possibly grab. Is K plus going to grab an H plus?
No.
No. Is K plus going to try and grab an OH minus if it could? Yes, but because KOH together is a strong acid, K plus can do nothing about pulling OH minuses out of it. Because if it could, wouldn't that change the overall acidity or basicity of this? Because the number of H pluses we have and the number of OH minuses, mustn't they always equal 1.0 times 10 to the negative 14 at 25 degrees Celsius? And mustn't each of these be equal to 1.0 times 10 to the negative 7, each of these, if it's neutral? So if I throw a salt in here and that salt does anything to either of these two things, either adds more or pulls some out, will change the pH of something. If I happen to throw K plus into here, because K plus with OH minus would be a strong base, K plus will never hook up with OH minus. Therefore, K is going to be neutral. Are you with me?
So when it's neutral, it doesn't do anything.
Neutral is going to do
pH
nothing.
or
And
pH.
it's only neutral when the cation is the conjugate of a strong base. Now let's look over here at our F minus, right? If we take a look at our F minus, well, we're going to try and put it together with HF. Now watch, if I have HF and F minus, is HF a strong acid? No, it's a weak acid, right? If it's a weak acid, won't it mean that this is a weak conjugate base?
Wait, weak acids have weak.
This is, and this is what's really important. I'm glad you asked that here. So, the conjugate of a strong acid is a pathetic weak base. This conjugate of a strong base is a pathetic weak base. The conjugate of a weak acid is a weak base. The conjugate of a weak base is a weak acid. How weak they are depends on how strong the weak acid is. Really important. I was going to hit that a little bit later, but I'm glad you brought that up. So this is true. Strong acids will have a weak conjugate base. And by weak, can we just substitute the word pathetic? Like do nothing?
If you want.
Really weak.
A weak acid will have a weak conjugate base. Because weak acids only dissociate about 5 to 10%. So that means that, now, we can have varying degrees of weak acids. That's why we have Ka values to help us with that. You guys grasp this here? It's really important you understand that, because the general idea would be this. Oh yeah, if my strong acid has a weak conjugate base, right? Then wouldn't my weak base have a strong no, that's not how it works. There's only 6 strong acids. And none of them have conjugates that can reform the strong. So you're never going to have a weak base form a strong acid. It will never happen.
So how do you get a strong conjugate base?
You never get a strong conjugate base. You will always get weak conjugates and weak conjugates. It's just a matter of how weak.
Okay.
Because if you have a strong conjugate, it means that it is a strong base or a strong acid, which means it would have no conjugate to begin with. Now, lest we get into craziness here, can we go back to this for a second? HF, would you all agree that that's a weak acid?
Yes.
Do we know why it's a weak acid?
Because it's not a
It's not part of CBS PIN, right? If it's not part of CBS PIN, it's going to be a weak acid. Therefore, my weak acid, if I were to throw this into water, just to show you how it would normally work, if I threw that into water, wouldn't it then form F minus and H3O plus?
Yeah.
this is the conjugate base of this weak acid. It also is a weak base, but depending on how strong this weak acid is, and there's a scale, right? So K values, I mean, we could have a Ka value that is 1.0 times 10 to the negative 15. Is that going to be a very strong acid? Or let me ask you this, which of these is a stronger acid? Something that has a Ka of 1.0 times 10 to the negative 4, or something that has a Ka of 1.0 times 10 to the negative 15? Which is stronger? Well, this is a really important question.
I don't know.
Isn't my K the amount of product of a reactant?
Yeah.
So if I have any equilibrium problem, so let's say I have HA, right? And it goes to H plus and A minus. If I write the Ka expression, wouldn't it always be H plus concentration times A minus concentration all over HA, right?
Yeah.
Would you agree the bigger my Ka is dependent on how much H plus I have, right? So if I have a larger Ka and a lower Ka, wouldn't this Ka indicate that I have a stronger acid than this one? Yeah. But the stronger my weak acid, the weaker my weak base. So this would have, and remember, don't we go Ka times Kb equals 1.0 times 10 to the negative 14? Yeah. Right? So if I'm dealing with a weak acid and a weak base, combined, they always have to equal 1.0 times 10 to the negative 14. So if I gave you, let's say on this side, 1.0 times 10 to the negative 5 as my Ka, right? That's not a strong acid, agree? Strong acids are like 3,000 or 10,000 or whatever. They 100% dissociate. Wouldn't that mean that my Kb wouldn't it have to be somewhere in the range of 1.0 times 10 to the negative 9?
Quick
Right?
math.
It's going to be weak as well. Both of them are weak, but would you agree with me that my weak acid is stronger than my weak base conjugate is in this case? Now, that was a lot of stuff that we just talked about, but let's come back to this here and what we were actually trying to do. So we were trying to get to whether or not Kf would be an acidic salt or a basic salt. So we know that K is the conjugate of a strong base and it's going to do nothing. But F is actually the conjugate of a weak acid, which means that this is a weak base. What happens if I have something that's neutral and then something that's a weak base? Won't the weak base do what it does in water and make it basic? Yeah. If I threw F minus into here, wouldn't the F minus start messing around here and changing the amount of OH minuses I have? Wouldn't it add more in? Yeah. Are you guys with me on this idea? Yeah. So if I took F minus and I threw it into this solution right here, wouldn't the F minus have a few things it could react with? Wouldn't the F minus potentially grab H pluses out of the water to form HF, right? And wouldn't the F minus, when it's doing that, if I put that together with water, wouldn't it also, as it's forming more HFs, wouldn't it also form more OH minuses? So wouldn't it do two things here? Wouldn't it pull HFs out? Or wouldn't it pull OHs out? And wouldn't it, I'm trying to speak that again. Wouldn't it pull H's out by forming HF, and then wouldn't it also add more OH minuses? So wouldn't that make the overall solution basic? Now, blah, blah, blah. All we need to know is this. If this is a conjugate of a weak acid, then this is going to be basic as long as this is neutral. Are you with me? Conversely, what if I gave you something that looked like this? What if I gave you ZnCl2? And I asked you, is that an acidic or is that a basic salt? Fair enough question, yeah? Let's go one at a time. Now here's the trick. If you were really good with Lewis acids and Lewis bases, you could go, oh, Zn2 plus, what is it going to do in here? Right? And it's going to form these complex ions, which we're not going to get into. But what I would do is this. The trick way is going, what if I put Zn together with OHs? Wouldn't that give me ZOH in parentheses 2? And the question I want to ask you is simply this. Is this a strong base?
No.
It's not, because isn't it one strong caliber? Isn't that our strong base?
Mm-hmm.
So this isn't a strong base, which means what about this Zn2 plus? Doesn't that mean that this is a weak acid? Not a pathetic acid, because pathetic acid means that you are neutral. wouldn't that mean that this right here, the CN2 plus, if we're doing the structure right here, this is going to be a weak acid. True story? So if I threw that into my water, wouldn't it be helping to produce H pluses or get rid of OH minuses? How about my Cl? Our trick, isn't it, to put H in front of it? So if I have HCl, what is that? Strong acid. So what would that make Cl minus? It'd make it a pathetic base, which would mean that Cl minus is neutral, right? And if it's neutral, and this is acidic, wouldn't it be overall an acidic salt? Say it.
Are we gonna compare the salt KPK and KPK?
Yep.
They both come to
There it is. He just gets the gold star for doing this. So
I'm confused.
go ahead.
I don't get how you're getting all of this.
Okay, so then phrase that as a question, a little more narrow question.
How did you get any of that?
Okay, that's not as narrow as I would like, but
Well,
okay.
start with, like, can you do another one and go really slow?
Okay, so one of the
Like
things that we
an
want
easy
to one of the things we want to do is we want to determine whether or not this or this is the conjugate, is a weak conjugate.
Mm-hmm.
The first thing here, the cation is always going to be your acid. Your anion is always going to be your base. Always. That's how in with Lewis acids and bases, the cation is a positive ion, and that's an acid, and the anion is a negative ion, and that's a base. So we want to know whether or not either the acid or the base has any strength at all, and if they both have some strength, which one wins? Because that'll determine whether or not you're acidic or basic. Now, if I were to give you the most common one that we see ever, which is NaCl, let's go back to that one. Would you all acknowledge that Na, that's going to be my acid, right?
So NaOH.
And Cl is going to be my base. Agree? We just need to know what they are conjugates of. If they are conjugates of strong acids or strong bases, they're pathetic and they don't impact our pH in any way. If they're, however, conjugates of weak acids or weak bases, they will actually impact our water in some way. So in this case, we look at Na, and what we could actually do is Na plus, right? We could actually say, what happens when we throw Na plus into here? And if you knew stuff about stuff, you go, well, Na plus is not going to do anything in here. But let's say you didn't know stuff about stuff. Here's what we do. We go, well, let's take a look and see whether or not it's part of our strong bases. Because if it's not part of, if Na plus and OH minus together was part of our strong bases, then we're going to know what this conjugate Na plus is. So if I make this and I go NaOH, I realize that NaOH is a strong base. Yeah?
Yes.
And if that's a strong base, that means that this conjugate of it is pathetic conjugate acid. Which means that if I'm looking at this right here, a pathetic conjugate acid means that it cannot do anything to try and get to NaOH again.
Okay.
So if NaOH breaks apart, so if I were looking at this as a reaction, it'll form Na plus and OH minus. This will never, ever, ever, ever go back this direction.
So Na is a weak.
Na plus is a weak acid, so weak that it can't do anything. So when it's in water, it doesn't do anything. It doesn't impact our H plus or OH minus concentrations. So this makes this neutral. Because this is pathetic, a pathetic acid, this is neutral. Now let's look over at our Cl minus.
But wait, why can't it just be a weak acid?
Because weak acid by default can grab, can release hydrogens or can grab OH minuses. If you're the conjugate of NaOH, conjugate of a strong base, strong bases, they do not allow anything to come back this way. That's why I did all these arrows and crossing through. So if my Na plus and OH minus, the conjugate of this acid, of this base, is Na plus, right? And because that's the conjugate of this, it can never go back this direction. It can never grab hydrogens or OHs or anything. That's why we look at it and go, it can do nothing in water.
Okay.
Because the reality is, what this is we throw this into water, right? And then it breaks apart into these two things. Same thing works with our Cl minus. Now, we don't think of Cl minus as a base because it really does nothing. Because if we take a look at it, HCl when it breaks apart, forms H plus and Cl minus. But this is a one-way street. There is nothing coming back this way, right? So if I take a look at my Cl minus, it's the conjugate of HCl. Since it's the conjugate of a really strong acid, this Cl minus will do nothing.
Okay.
So that means that it's pathetic base, and it will do nothing as well. So that means that it affects water none. So if I have a neutral cation and a neutral anion, that only happens when they're conjugates of strongs, this overall ionic compound does nothing.
Okay.
Now, what if we start varying it up? What if we did something like this? Ready? Let's go NH4Cl. I'm keeping the same Cl because I'm hoping you guys will remember, isn't Cl minus always going to be the conjugate of a strong acid and do nothing? Are you with me on that one, Emma?
Yes.
So this, I'm not going to go for the same reasons we know before. Isn't this going to be neutral because Cl minus is the conjugate of a strong acid? True story?
True story.
But what about NH4 plus? So if we take a look at NH4 plus, there's a couple ways you can do this. One, you can know that NH4 plus isn't it the conjugate of NH3,
Yes.
right? And NH3 is not a strong acid. Another way of looking at it is this. If you did NH4OH, this is the trick way that I do it. I look at this because I know that the only strong bases are ones that are group 1 with OH plus Cal strong pairs. Is NH4 part of group 1 or Cal strong pairs?
No.
No. So wouldn't this right here be a weak base? By the way, super fun fact, NH4OH really is NH3 plus H2O. You will never see this written. In fact, this is something that in our when we did solubility rules, the weirdos, I told you they can never write NH4OH ever. It's always written as this. So in essence, we're doing the same thing as saying NH4 and NH3 are conjugates of each other. But what I know then is this: NH4 plus will not be pathetic. NH4 plus is not the conjugate of a strong base, it's the conjugate of a weak base. Conjugates of weak bases are also weak acids. You can never go from a weak acid to a strong base or a weak base to a strong acid. You just go to varying degrees of weakness, which is what you guys both asked very astutely. So what does that mean here? That means that this NH4 plus is actually a weak acid. Well, if I have a weak acid and I have nothing, wouldn't the weak acid then make the salt acidic?
So there's a difference between a pathetic acid.
Yep, pathetic does nothing. And pathetics are only the conjugates of strong. So we look for pathetics.
We like pathetic.
We like pathetics because it makes our problem easier, because we know we look at that and go, and incidentally, they're going to use a lot of the same ones over and over again. You're going to see CLs a lot. Because how many strong acids are there? Aren't there only 6 strong acids? And 2 of them are kind of weird. Perchloric acid, kind of weird, right? HClO4 minus. And then don't we have sulfuric acid, which is a polyprotic acid even? You're not going to see those in a lot of these problems. Are you with me? Now, the same exact thing happens, but reverse, if we go the opposite way, where we have a nothing at the front. So let's say I go, again, let's go with an old one that we know. Let's go Li, and let's go Li, C2H3O2. Although wouldn't we call it Chiku? And they might write it like this just to mess with you. These two things are the same thing, right? Are you aware that the positive ion is always an acid? The negative ion is always a base. Always. So then we look at these two and we go, all right, the trick is, this is an acid. If I put an OH with it, will it be a strong base? And what's the answer to that? Where's Li?
Well, it's at the.
It's in group 1. Isn't everything in group 1 with OH, isn't that a strong base? So without doing anything farther, couldn't we say that Li will be pathetic because it is the conjugate of LiOH? A little bit? Help me with this. C2H3O2, right? Or CH3COO, isn't that what this is right here? If I put a hydrogen in front of that, Please tell me you don't think that's a strong acid.
It's a weak.
It's a weak acid. What does that mean therefore about this? Will that be a pathetic base? No, won't it be a weak base? So this weak acid, its conjugate will be a weak base. And if this is a weak base, and I have pathetic and weak, wouldn't this become a basic solution? A basic salt? Now, ready? He just hit on it. Are you with me, Emma? Do you have any further questions here? We may have to work through some of these to feel
Yeah.
comfortable. So what if we have one of each? So I'm going to do this for you here. Nope.
Oh, it would depend on the numbers.
It would depend on our numbers. So let's do this one. NH4 ClO. Now, you're going to get really good at doing these by just looking at them. Didn't we just do NH4 and don't we realize that this is a weak acid? Is everyone okay with that? It's a weak acid. ClO, only if HClO is a strong acid will that make this pathetic and neutral. But HClO, is that a strong acid? Nope. So what does that make this? It means this is a weak base. Isn't that the conjugate of this? Are you all with me right now?
Yeah.
So I have my NH4 plus as part of my salt is a weak acid. My ClO is a weak base. How do I know whether or not I'm acidic or basic? If they had exactly the same, we have to go to what? Kas and Kbs. If the Ka of my weak acid is bigger than the Kb of my weak base, it's acidic. If my Kb is bigger than my Ka, we're basic. If it's equal, which never happens, you'd be neutral, right? So we probably ignore K values here, right? So if I take a look at this, my Ka for this is 5.68 times 10 to the negative 10. My Kb, let's get rid of this so you don't get confused. My Kb for ClO minus is equal to 3.45 times 10 to the negative 7. What will this be then? Acidic or basic? Well, we're going to play the game called which number is bigger. This is my Ka. It's times 10 to the negative 10. This is my Kb. It's times 10 to the negative 7.
If they give you a KB, then do you automatically?
You're likely going to know
Do you
automatically.
even have to do that? Like, say I'm on the AP test, I have.
Oh yeah, I would jump right to it and I would go, yes.
For like justification.
Yeah.
Wow.
You literally, if they gave you the K and the KB in the problem, you could immediately solve it. Any questions right here?
No.
Okay, hit pause on that right there because that's going to be the video on salts.
Ready, guys?
Wait, I want to say hi.
Hi, classmates.